All right, everyone, I think we're going to start this off. We were just waiting a couple of minutes for people to pile in, and we have quite a few people on Zoom already waiting for us to start. So I'll say a couple of words, and then I'm going to hand the microphone over to Heiko before I start with my first talk. This is the first event we're doing in collaboration with the London NLP group. We usually do all of our open NLP meetups fully virtually on Zoom. So it is a bit nerve-wracking today because this is the first time I'm at least hosting an in-person meetup. And today we're going to have two speakers. One of them is going to be myself and the other will be Sam. I don't know where Sam is, there he is. And yes, so I'm just going to hand over to Heiko because he is the second host for today.
Thanks, Tuana. Hi, everyone. Thanks for coming out. My name is Heiko Hotz. I'm the founder of NLP London, a meetup group about NLP here in London. Very self-explanatory. We've been around now for 2 years or something like that. Many decades, yes. So even before the whole ChatGPT thing, but obviously natural language processing, large language models is now, even more popular than ever before. So I'm really glad that you all came out and that we have two amazing speakers today. Tuana, she's going to talk about how to build LLM application, so that's an application with an LLM powering the application and build memory into that. And then we have Sam talking about just how to get started with LLM applications in general from zero to hero. Yeah, that's me, and Tuana, over to you.
Thank you very much. All right, so a quick reminder for everyone who's joining us on Zoom. You can use the chat to ask any of your questions. We have a couple of people from DeepSet who will be answering along the way, but we are going to dedicate maybe about 5 minutes at the end of each of our talks to answer questions. We have Bilige sitting over there, so if anyone has questions online, she's actually going to forward them to us, and then we'll take a few questions from people here if you have any as well. All right, so let's give it a start. I'm going to be talking about building large language model-based applications. Specifically, I'm going to be discussing memory, why we're even talking about memory when we're talking about large language models, and a few of my ideas about that. So this is the general structure I'm going to somewhat follow, although I won't stick to it too rigidly. This is not very deep technical. I just want to have this be more of a sort of discussion around what we can do with large language models now. And I'll start with how the most basic way we can interact with large language models. Then I'll discuss a very particular style of prompting that gave rise to, I'm sure, a lot of you have already heard of the term agents. And then we'll start looking into memory for large language models, why we even talk about that. And then the last slide is just my brain dump about what I think might be the follow-up discussions when it comes to memory and LLMs. All right, so let's start simple. Here's large language model. This is obviously a very specific example, but just to depict the idea, this LLM might know everything online up to New Year's Day 2022. It is very good at languages. It's fairly good at following instructions. And a lot of the large language models we've been hearing about are exactly like this. Recently, I find that the term LLM is also quite synonymous to generative models, and models that you've, I'm sure, heard about, GPT and Falcon and Claude, etc. All of them fall into approximately this category. And what can we do with these large language models? Well, let's start very, very simple. You can ask it questions. You can say, where is Istanbul? I get the answer, Istanbul is in Turkey. But what's slightly more difficult with large language models, I'm sure you already recognize this interface as well. This is ChatGPT. But what if I ask it something like, which meetup group is Open NLP Meetup joining in London? And if I ask this question to a particularly good large language model, I might get a response like this, because it doesn't know, because it let's make it up again, maybe knows everything up till New Year's Day 2022 when we weren't doing anything. How do we sort of navigate this issue right now? The next slide is actually a very simplified example of what we call retrieval augmented generation. Here I have given an instruction and I've said answer the question given the context, and this is actually the first paragraph of our Meetup page for this day, and I've given it the context of the introduction to this Meetup. And then I say question, again, the same question, which Meetup group is Open NLP Meetup joining in London? And in our description on our Meetup page, we described it as our London NLP sister group, and now I get the answer, London NLP sister group. All right, so how do we actually make this work in an application? Very briefly, I'm going to discuss Haystack because I am here for Haystack technically. So the company I work for, DeepSet, we have an open source NLP framework called Haystack, and the general idea behind Haystack is providing all of the tools for developers to build NLP applications. And just focus on the arrow, this is quite a complex diagram, but the basic components might be a document store that you can pick based on what you want to build your application on top of, where you have all of those documents that might include your own information and data. And you might then want to prepare those documents somehow and write them in a way that any model, whether it's a large language model or a simple transform model that does extractive QA, prepare it in a way that they can actually use these documents. And then finally, the most interesting part is the actual NLP application pipeline you would want to build. This is a classic example where you don't really need to understand for this presentation what a retriever actually does, but it could be a retriever followed by a generator component, and we provide tooling for engineers to pick which model provider they would like to use, whether that be open source from Hugging Face or OpenAI or Cohere and so on. So that's a Haystack plug out of the way, but how do we actually interact with large language models in Haystack? Because a lot of my talk is going to be based on that. So the two main components that we have in Haystack that allows you to interact with large language models are prompt templates. And this is basically your blueprint of how you decide your interaction with an LLM is going to look like. And the second one is a prompt node. And this is basically your interface to interact with a large language model. This is the component that tells us which model we're using, whether that's from Hugging Face or OpenAI or SageMaker. And it's a component that is sending the final query, which is basically defined by our prompt template. And it is also the component that receives the answer from a model. All right, so what might a prompt template look like? Here, we have an example prompt template where we say, given the context, please answer the question. If the answer is not contained within the context below, say, I do not know. And then I say context, and the most important thing here is what you see in curly brackets, documents. They're also blue. I hope people at the back can also see that. But basically what this means is we're telling our prompt node that anything that we're sending to a large language model or model is going to be inserted into documents at query time. The documents will be inserted into the prompt itself, so will the query. And then how might I use that with a prompt node? Again, as I said, this is the component that we actually use to interact with a large language model. I might say I'm going to use something like GPT-3.5 Turbo, and then I simply call prompt node genqa prompt.prompt. I tell it what prompt template I want to use. It's the one I just defined before. And then I give it a query. Who is giving the talk on memory, for example? So in this scenario, I might imagine documents being the paragraph I had from the Meetup group. I think I actually made this. And here I actually built this prompt node here. This is the prompt template you just saw before.
Excuse me, could you zoom in?
Yes. Is that better?
A bit more.
Okay, hopefully that's a bit better. But I think I won't run these code cells, but basically, what I've done here is I've said the document that I'm providing is that paragraph about my talk, and I am then inserting it to my GenQA prompt, and then I'm saying the query. For example, here I said, who is Sam, the last time I ran it, because at this point my model should not know anything about Sam, because I have not provided any documents containing anything about Sam's talk, and it gets, I do not know. All right, so let's go to the next one. The other way you might be able to interact with a large language model, so this setup was me actually manually putting in the document, but one of the most powerful ways you can potentially build a more scalable application is to build a pipeline. And the way you build a pipeline is you simply add nodes, and what you end up with is, look at the image below, and a node is followed by another node and another node, and what they're doing is they're just forwarding each other data until we have a final answer. And this image I'm going to come back to, because it's actually one of the core concepts of how we build NLP applications with Haystack, but it is no longer the only way. And this one-pass system is going to be important to understand how the other way we interact is quite different. And in this pipeline, I have two components. I have a retriever, and as I mentioned before, retriever, very, very simply put, is a component that, given a query, can go through a large set of documents and extract the top, let's say, 5, here I've decided to run it with top 5, most relevant documents in your data set. So if I were to precede the previous prompt node with this type of retriever, what I'm doing is I'm injecting the most relevant documents from maybe thousands of documents into the prompt itself before I send it to the large language model. This application, you can actually scan this QR code. It'll take you to a Hugging Face space that's, I'm hoping, still up, because it does go down quite often. It's built with this exact scenario in mind. So for me, the concept here was the retrieval augmentation bit. I wanted to do some sort of Twitter stream search. So I wanted to be able to provide a username, a Twitter username, get the latest, I don't know, 60, I think, tweets. Retrieval augmentation bit, and all those tweets are injected into my initial prompt, and then I design a prompt in a way to look at the tweets and give a sort of Twitter voice for this user. So I prompted the large language model to say, look at the provided tweet streams and let me know what kind of tone they use, what languages they use. The weird idea behind this was that I can put in a username and then see if this is someone I should follow or not, whether they're posting stuff that I would be interested in. Here's an example of the Twitter user handle Dog Feelings. There's a Twitter account called Dog Feelings, and I got a pretty nice reply for that. It says, this user has been tweeting a lot lately about their experiences as a pet. They tend to tweet about being a good pet, etc., etc. All right, so on to what we call agents. So again, everything I've explained so far is based on this one-pass system. A node is followed by another node is followed by another node, and quite often it has access to one knowledge base, and data is forwarded from one node to the other until we reach the final point and our time with this pipeline comes to an end. But there is a different way you might pick to interact with large language models, and this image here is a very, very, very simplified view of what an agent is actually doing. Here, I've made up this instruction completely. These tools do not exist, but I have told the LLM, you have the following tools, and I have said one of them is called Twitter Retrieval Tool, useful for when you need to look up a certain Twitter user's tweets. And then I have Web Search Tool, useful for when you need to search the web to learn more about a topic. And then I instruct the model to pick which tools it would use in what sequence and why, to answer the query, if the Twitter user Tuana Çelik would post about the heat waves in Italy, what would that look like? And the answer I get is actually quite cool, because it's a pretty good description of which tools it would pick, for what reason, in what order. And this basic prompt, this style of prompting, this idea, is what is behind the concept of agents. And the reason it's very different to what I was showing you before, where a node was followed by a node was followed by a node, is there, me as a developer, I was the one picking the path that the application is going to take. Now I'm offloading that duty to a large language model. Sometimes it works perfectly, sometimes it doesn't work perfectly at all. But the idea is that the path is really not predefined at all. We're offloading the duty to a large language model that every step observe some output from an actual tool that is running and decide what the next best tool to pick and action to take is. And these tools might be, again, actually web search. I might actually build a Twitter retriever tool. I might have a completely different retrieval augmented generative QA pipeline that I built. It's really up to the developer. I am not going to go really through this. This is, if you are interested, we have a new prompt hub for Haystack, where we share the prompts that we've developed that you can then pull in and use in any Haystack pipeline. Maybe I can actually go to this just very quickly. By default, an agent prompt is based on this zero-shot React prompt. It's based on 2 papers. One of them is called React, the other one is called MRKL, and you pronounce it Miracle Systems. And this is, if you are interested, I recommend reading through this prompt, because you'll see that in curly brackets we actually have tool names with descriptions. So every time I add a tool to an agent, it actually gets injected into the prompt so that the large language model knows which tools to pick from. All right, let's go back here. And then let's have a look at what I might actually end up building with this. So this, again, is another QR code that will take you to another Hugging Face space, which is an agent that is running that does actually have those 2 tools we looked at. It has a Twitter voice, a Twitter retriever, I don't remember what I called it, tool, and it has a web search tool. And the idea behind this was to actually build an application where I might ask if the Twitter user Dog Feelings were to write a tweet about, in their style, about the Elon v. Zuckerberg fight, what would that be? And the idea here was to test whether, well, this LLM most probably has no idea about this very recent Elon v. Zuckerberg fight that was on the news a couple of weeks ago. So would it pick to use web search to find out what that is about? So I ended up with something like this, where I have just 2 tools, and I ran the same query. And you really do not have to be able to read this. I'm just going to read it out to you. The first tool it picked was Twitter Voice Tool. It retrieved the tweets from Dog Feelings and came up with a sort of summary of what kind of styles they tweet about. And then it picked web search, and the tool input was Elon versus Zuckerberg fight. That was it. And then the final answer was, the final tweet that it decided that this Twitter user would tweet about was, "Oh heck, the human told me Elon and Zuckerberg are gonna have a cage fight. I hope they bring some squeaky toys," etc., etc. It's pretty good. All right, so why do we even talk about memory then? And the best way I thought I could depict this was thanks to one of my colleagues who just wrote an article about memory for large language models, Isabel. So I stole this from her. But the idea here is, let's say we have an agent, which just very simply think of an agent as a large language model at this point. Don't think about tools, etc. It's a large language model that we're interacting with. And let's say you have someone who asks it, "Who is Picasso?" And then the large language model replies, "A Spanish artist." Now, the problem here is the world in which this large language model is interacting with us is that box and nothing more. So if I then follow that up with another question, when was he born? Well, I just made up this answer, but it's going to tell you something like, "What are you talking about, mate?" Or it's going to be a model that's not great at detecting that it doesn't know about something, and it's going to hallucinate something. Because anything that goes on the top bit, well, that's no longer a part of its world or of its interaction with you. That's where the concept of memory comes in. And the concept of memory is simply record my interactions, my conversation with a large language model, and use the same exact strategy we use with all of the rest of the retrieval augmented bits we just saw, where we inject documents, for example, or tool names with descriptions. And the very basic idea is this. In Haystack, we call this a conversational agent, which is simply a large language model that has access to some sort of memory, and we call this a conversational agent. And the way this happens is every time we have a query, that is recorded in memory, and it's also injected into the prompt, and everything we had in the memory up till that point is also injected into the prompt. And this whole prompt that consists of my current query and everything in memory is sent to a conversational agent. Finally, we get an answer, which is then also recorded into memory. Now, what might that kind of look like? And this is a very simple conversational agent prompt, where I simply have the following is a conversation between a human and AI, and I have memory, and I'm filling this memory in at each iteration of my interaction. And then I have query, and then I wait for a reply from the AI. Now, what might be the problem there? We record the conversation in the prompt itself, and the very obvious problem here is context window. We don't have infinite space to interact with large language models currently. So imagine a scenario where I have this conversation and I filled up the context window with my memory up to this bit. Well, the next time I have an interaction, and the next time, and the next time, I'm either going to be losing information that I need for memory to be accurate, and it's just not going to work so well after that point. So how do we sort of navigate this? This is where in Haystack we have a concept called conversation summary memory. Very simply put, you can initialize it as conversation summary memory, and what it does, it condenses the chat transcript into a very short description of what I've spoken about so far. And you can also pick to maybe wait a couple of iterations before you create a new summary. And then how might you add that to a conversational agent? Well, you just declare a conversational agent the same way you would any other agent, but you then provide memory. And in this case, I decided I would provide summary memory. If not, you can still provide the most basic type of memory, which is simply put the whole conversation transcript. But at that point, you are probably going to be running into context window limits. All right, this is where it's mostly about my thoughts. What we've done so far with everything we've built, if we do include memory in any type of interaction with a large language model in the way I've just been talking about, we are building Dories. I don't know if there's anyone who hasn't seen Nemo, but Dory is an adorable character. She can hold conversations, but unfortunately she's not great at retaining conversations over a long period of time. So what happens if we start talking about memory for large language models that persist over time? And this is more of conversation, to be honest with you. This is not something I have an answer for. I would love to hear what people here think, actually, is if we do want to persist memory in some way. Right now, I've shown you how we can have some sort of memory while we are interacting with the same agent until we kill it. What if I want to have a sort of agent that, for example, a customer then can come back to continue the conversation they had 2 weeks ago? This is where memory starts to we start blurring the lines between memory and document store, where we actually held our documents that we can always connect back to. And I'm interested to see whether we see people building conversational agent tools that are memories, which is already possible in Haystack, where we maybe keep a record of memory that we can always come back to. This is where I think I do guess we might start seeing changes in how we approach memory for conversational agents. If you do want to start building applications that uses this style of interaction with LLMs that also has memory. Two QR codes here. One of them is a tutorial on our website, which is the most simple form of conversational agent. It's a way to build a very simple chatbot. And then the second one is an article about memory for large language models, which a lot of my talk was actually based on. This was written by Isabel from DeepSet. And that is it from me. Hope you enjoyed that. And I don't know if there are any questions online, but if there are any questions here, I'd love to answer them. Questions? Okay.
Thank you very much for the presentation, quite interesting. Your concept of creating a somewhat of a temporary memory within, for example, AI is I think it's quite an interesting thought actually. And actually, at the end of the day, it should probably be done eventually if you want to either audit, I mean, for example, large language models in the future, just to make sure, make sure there aren't any sort of rules being broken, that sort of thing. But still, quite interesting. Thanks a lot.
So the first question is, how do you make sure that summarized memory context details are not lost during multiple summarizations?
That's the detail we didn't go into at all during this talk, but maybe I can actually quickly switch over to that. The conversation summary memory was actually a prompt node that was that had a prompt template that instructs the model on how to summarize. So the question is, I think number one, it's going to be based on your choice of how you want summary to happen. In our scenario, we used another large language model where we're instructing it how to summarize the context. You do risk losing context, obviously. So there are a few techniques you can do. This can be anything from deciding how many iterations to wait before you create the summary. It can be even deciding to change your initial conversation summary prompt and use a model that's quite performant in following instructions and tell it exactly how you want that summary to look like. And I can also potentially even tell you okay, this is the prompt that we were using. This is the default conversation summary prompt that we use. And it simply says, condense the following chat transcript by shortening and summarizing okay, we have a bug here, I can't actually go, without losing important information. And I believe, I'm not sure which model we were using here by default, but it's probably one of the GPT models, and this was actually quite good. And what I noticed was, and Isabel also noticed this because it was in her article, is that this prompt in combination with the model that we were using, and I want to actually reiterate this because this is something I've been noticing recently. It's not just about the prompt, it's the prompt and model combination that defines the success of how well the result is going to be for your use case. With the model and prompt combination we were using, we got a pretty good summary, but it always kept the last interaction in the summary as well, the previous interaction. So the last human AI query and response was always in the summary. So that's my sort of convoluted answer to that.
Thanks for your presentation. I think the idea of creating summaries is a really nice one. So I was thinking, do you feel the costs of doing inference on summarization as well as generating text is worth it? Also, is there any way to intentionally make the system forget something? Say in the context, you have a previous conversation, but you don't want that conversation to affect future conversations. is there any tip at the moment to like intentionally forget certain things in the summary? Yeah. Thank you.
Okay, so I'll try to answer that question in two bits. Number one, I do see the advantage of definitely doing summary, because if you intending your application to be used for very frequent interactions, don't forget that if you do want memory, every time the whole thing is being sent to the large language model. So that's actually a lot that you're taking up on your context window. Whereas in summary, if you could even maybe define the exact length of what that summary is supposed to be, and you know you're not going to be going above that at each query. And yes, then you have the problem of maybe losing some context. I don't remember what your second bit of the question was. I feel like there was a second bit. So could there be any advantages? I think this is completely up to what you intend your application to be. Of course, there might be scenarios that where you want to make sure that actually very old conversations are not being any sort of influence on your current conversation with a large language model. There might be applications where that is very important though. And if we're talking about super long conversations recorded, and we want to make sure the whole recorded conversation is being considered for your next reply you're getting for a large language model, I do think maybe one day talking about memory that's persistent is probably going to be quite important. There's one more question over there, and then I think we should hand over to Sam.
Questions. Okay.
It was a really fantastic and comprehensive presentation, so thank you. A question on the retrieval augmented generation bit. So in the example you gave, presumably you manually copy and pasted the relevant piece of text in. Could you talk a bit more about how you can automate that potentially around embeddings and vector databases and all that jazz?
Runner here. Okay, so that bit is the bit that I sort of glossed over, but the idea is that Haystack pipeline always has access to a document store, and that could be a vector database of your choice. Let's say we go with something like Weaviate or Pinecone, and the retriever, actually when you're indexing, is the component that creates embeddings or vector representations for all of your documents and stores that in the vector database of your choice anyway. At that point, the best thing to do is not what I did where the manual pasting that was mainly to show exactly what's happening, but then you build a pipeline that has a retriever node followed by a prompt node, anything that's a generative component, and when we ask a query, the first thing that reacts is the retriever node. And then by default, the way it's set up is actually it's put into the documents parameter. And there you can decide, do you get the top 5, the top 3, the whatever, yeah. All right, I think we should probably hand over to Sam at this point, so I'm going to invite you over here and I'll stop sharing my screen.
Hello, everyone. 1 second while I just get set up and share screen. Host disabled screen sharing. Who is hosting? Anyone here? Okay, we've got it. Yeah. Okay, awesome. Do we need to show anything else? Is that it? Can I just go ahead? All good? Brilliant. Hi, everyone. My name is Sam. I am currently working in a data team for a fintech. And then on the side, I build things with LLMs, I play around with LLMs, I write about LLMs, all things AI living and breathing all the time at the moment, which is great. And today I'm basically going to give a rundown on how you can use LLMs to supercharge development in all aspects, essentially. And if you kind of adopt this AI first mentality, which I feel like I've tried to have at least this year since ChatGPT came out, then I really think that there's a lot of benefits to doing so, and I hope that I can convince you of that tonight. So where do we start with AI? Well, obviously, ancient Sumeria. So if we go back just a little bit and we kind of think about the first sort of computing devices which humanity have ever used as far as we're aware of, then we have these stone tablets from Sumeria, the Sumerian abacus. And I think what I'd like you to take away from this idea is that complex societies have a need for computation, right? We need to be able to organize things and plan things, and we need to be able to do this in such a way which is scalable, because our human brains can't really handle things much above, 20 plus 20, or at least mine can't. So, sorry, I'm going to try to keep the stand up to a low level. And then also we've got other examples, if anyone's an Indiana Jones fan and has seen the new film, the Antikythera mechanism. So this is sort of an example of an analog computer that we found from the ancient Greeks, and we don't really know exactly what it's for, but it's most likely due to kind of calculating astronomical positions. And just generally, I think that automation is a constant pursuit when you're trying to grow a society and you're trying to build new things. And this AI step that we're now taking is only the next phase of that. Is the next phase. So how do we get to this space? So if we go back to the 1940s and 50s, we have Alan Turing, and Alan Turing really was kind of the pioneer who was pushing for these first ideas of what would it mean for a machine to think. And he proposed the famous Turing test, which I hope many of you know, but just people who are new to kind of the idea. Essentially, if you can speak to an AI and you can't tell that it's a person, then it's a person, right? Then it's past cognition. And immediately that has a lot of problems, because what's the conversation going to be about? How long is the conversation going to be? What's the intellectual capacity of the person having a conversation? Because a child might say that a certain AI has passed the Turing test well beyond someone with an AI PhD may. So there's a lot of flaws with this, and I personally don't think we've passed the Turing test yet, even though it's not a real test. And this kind of idea, this concept, leads us to start wanting to build up techniques to make these systems. So some of the first examples are what we call good old-fashioned AI, and kind of these rule-based systems. And these were systems which don't have very good breadth of knowledge. They were very good at small tasks, fixed tasks, but they don't really have that kind of out-of-distribution generalization skills that modern AI has. And slowly we get a bit better with our computing, we get a bit better with our maths, and we start with some statistical techniques, some decision trees, some neural networks, and we go through a few AI winters and summers over the past sort of 40 years, and we get to where we are now, which is this advent of natural language processing, of NLP, where we have these tools and these systems which are able to, at a rate which lots of us can't fully comprehend what they're actually doing, produce text and produce code in a human way. And that is what we're going to focus on tonight. So the first example, I think, of a tool that's really went out there and kind of took the developing community by storm is GitHub Copilot. And hands up, just any of you that have used Copilot. And then now keep your hands up if you still use Copilot in your jobs or just day to day. Okay, so we got a few. And Copilot, for those of you who aren't aware, was a partnership between GitHub and OpenAI, and they used the model Codex, which was trained on hundreds of billions of lines of public code, essentially. And all Codex is a Copilot, right? It's a predictive thing which, as you type your lines of code, will come up with what it thinks is the most likely completion to your code. So this is great if you're doing a lot of repetitive tasks, and especially if you're learning to code as well. It can be a really good tool to have, start building a function, start building a game, and it fills it out for you. But the major problem with Copilot, which has sort of now been surpassed by these new tools, is this struggle that it has with complex logic. Because if you're only training something to predict the next line of code, it doesn't really get that good at understanding the full space of building a project, of understanding the steps that would take place if you want to, start from scratch, go from 0 to hero. So just generally, the impact of a tool like Copilot is it does reduce our development time, it improves code quality, and it can aid learning, especially for new languages. But generally, Copilot isn't great. And a lot of people I know, when Copilot first came out, was swearing by Stack Exchange way over Copilot just because they felt that Stack Exchange could get them answers very quickly. Newsflash, no one likes Stack Exchange. So if we move on slightly, I think the big thing now with AI is all you need to, sorry, just a meme. We have large language models, right? So large language models, what exactly are they? Well, without going into the technicalities, they are an exponential uptick in the abilities that we now have for a multitude of tasks, right? So they have a general ability to understand text, to produce text, and also understand code and produce code. And how these things are trained is, you take a huge corpus of text from the internet, and then you apply a bunch of backpropagation magic, thanks to Geoffrey Hinton, and out pops a brain. And without going into the specifics of that, that results in something where you can just ask for what you want. And if you're really good at asking for what you want, you can hit up one of those 300K prompt engineer jobs, and they'll pay you to ask for what you want. But for most people, you don't want to be doing that, and you don't want to be spending a long time prompt engineering and trying to figure out the best way to structure your prompts so it suddenly knows how to use the certain code base you're talking about. You want to be able to apply tips and tricks to be able to not go through that hazardous process. And before we start some demos, I would just like to point out, in everything that we do here, this is the worst that these things will ever be. Right? We see, compared to last year when GPT-3 was pretty much the only one that was around, and then when ChatGPT came out, and we have the reinforcement learning with human feedback to get to that stage where you can get it really fine-tuned so it's great for answering human questions and it's really aligned with human values. Whereas if we look further into the future, we're going to have these models which are way capable from what we have right now, and already, when you're waiting for a model to produce the answer, like, already you're forgetting that how insane this technology already is, and yeah, you might need to wait a minute for it to respond, but it's going to be a second in a few years' time. So patience is a virtue when it comes to the LLM space. So let's focus on the most important thing with LLMs, with a nice AI-generated image, which is ask and you shall receive. Because the robot overlords are here, and they really like helping us. So while they like helping us, here's how you can talk to them effectively. So we have ChatGPT here. GPT-4, for those of you who aren't paying, I would recommend it. I know there's been some things in the news yesterday about how GPT-4 is getting a lot worse, and that is true. There are examples of this, but I think they'll iron some stuff out, and the cognitive jump between the free version on 3.5 and GPT-4, it is insane, and I really would recommend, if you do feel like you want to use LLMs a lot and be an AI first person, pay for the subscription, see how it changes your day-to-day job, and see if you want to continue paying for that. So what we're going to do here is go through a classic sort of trick that I use pretty much every single day to help me develop a repo. And what we're going to do here is look at the code is kind of irrelevant, but what this file is it's a file called prompt.py. And what prompt.py does is it concatenates your entire code base into a single text string. It removes all of the indentation, it removes all the spacing, and if we run it for 1 second, and then we go over to the text file, it creates this text file, which is your code base, essentially, separated by the file paths. And what you can then do is you can take that and copy it into GPT-4. And if it likes the code, it will just say yes. So we've now set it up with kind of an instance of some code, of the beginnings of a base, of a repo, and now we want to build something. So just for some context, this class here, which I've given it, is the class which I use a lot. It's just called AI, and all it contains is essentially methods to access the OpenAI APIs, to do audio recording, to generate images, etc. So that's the base we've got, and then I would like if anyone would like to just suggest an AI-powered app. Any AI-powered app which involves images and text. Can be as basic as we want. We're just going to do a quick demo. Shout it out. Transcriber. Oh, you're making it difficult there. Transcriber. I said image and text. Summarizer. Okay. All right. So what we're going to do is we can type in, and I wish we had Whisper here, so I'm just going to type this as quickly as I can with the microphone down. What we're going to do is we're going to type in just something like build me a Streamlit, I can't type today, sorry guys, Streamlit app that summarizes text and then produces an image about it, right? So we type that in, and now with the additional context of what it's already got, it's now going to go through and describe all the steps, provide all the code, and make sure everything's running. So while that runs in the background, Streamlit, for those of you who haven't used Streamlit before, Streamlit is a very simple kind of Python-based app prototyping tool. You can just use to kind of get like a very easy app up on the ground if you just want to play around with things. And then there we go. We've got our app. So we will go back to the repo and let's just create a new file called app.py. And let's okay, it's decided to use, and actually, I'm going to stop for 1 second here. This is the classic example of it getting worse, because it hasn't had any problems with these in the past few days, and it's decided to use something called transformers pipeline, which is not in the original text. So I might just type in using the code above, and then we'll come back to this in a minute and try out that app again, because I think it's used something else. Okay, yeah, there we go. So now you can see it's using the classes that I already gave it. But while that is going in the background, let's go back to the slides, and let's just talk about LLM-based programming in general. So that's the thing at the top is the thing that I like to remind people, is that it is, and I think this is like the Dory analogy as well, LLMs are just very, very intelligent toddlers. Right? Like they have no grounding of what it means to be in the real world. They have no grounding of what it means for things to have consequences or creating errors in your code and things like that. They know more code than anyone could ever know. But unless you guide them the right way, unless you structure what you're saying in the right way, they're not going to do very well, right? So you always have to bear that in mind. And with toddlers comes patience, and that's the other big one. You need patience, you need flexibility. It's taken me a few months of repetitively using these tools to really feel like I can get the most out of them. And I think for a lot of people, that's a hard ask, because you want a new technology that you can just jump into and is user-friendly. But this is a brand new type of technology, right, where it's probabilistic, it's not deterministic. You have to learn how to say what you want to these things to get them to do what you want, and also OpenAI like to change how they work. So you might say something 1 month that just differently the other month. Okay, I think we could probably go back to our app now. And hopefully just, right, it's not working. Isn't that perfect? Don't we love that? Sorry guys, live demos can be a bit funny sometimes.
It's never a good demo if it works properly.
Exactly. It's telling me my, it's probably because it's forgotten to do that nice line there, but we can spot that pretty quickly. Name OpenAI is not defined. Right, so everything's breaking today. So we're going to leave this demo and we're going to go to the more fun demo instead. I'm sorry. What's the more fun demo? Yeah, so going back to this, AI first problem solving goes a really long way. If you go for the first thing for your Stack Exchange, you may feel like you're learning more potentially and you're challenging yourself, but if you really just want to build something, Stack Exchange is not going to teach you how to build that thing the way you want it, because you can't go on Stack Exchange and say, hey, this person who asked this question 10 years ago, can you apply this to my exact use case? And that's what you can do with LLMs. You can ask LLMs for very specific questions, and if the LLM that you are using doesn't work, you have multiple LLMs. There's Bard now, there's Claude, we have more open source alternatives. So So it's really a case of working out what is the best LLM for your task, what is the best LLM for what you want to do, and try the same prompts on different things and compare their answers. Okay, so I will show you something that I built using using ChatGPT. It worked. I built it yesterday, and it works pretty well. And it's just a basic conversational assistant. And this is built from the AI class, and then you just ask it to build you an assistant, and it has no problem doing that. So if we just run, I assume people can see just the terminal. If we just run that, okay, so it's recording audio right now. So, we're going to say something like, "Hey, ChatGPT, I'm doing a talk to a bunch of nerds. Can you tell me a joke?" Okay, and what we're doing now is we're transcribing that using Whisper, like locally, and then there we go, it's transcribed, and then,
Scientists trust atoms because they make up everything.
Very funny. Oh, it's still recording, so we can also, it has memory, so we can keep going, and we can say, "That was a terrible joke, can you tell me something about, I don't know, a fact about bats?" And then I'll stop it there. Yeah, so this is an example of a tool of something that you can build very, very quickly using LLMs. You can make your own Jarvis now if you want to, for free. So yeah, that's fun. And then there you go, there's a fact. Okay, so moving on to, I've lost my time. Does anyone know how long I've been speaking for? Ah, okay, all right, it's fun. Enjoying yourselves? 2 hours. Oh, look, people are leaving already. Ridiculous. I thought I'd be getting hecklers, not just people walking out. Yeah, so the other thing the point I didn't put on here is that when you're building things with LLMs, you don't want to bite off more than they can chew, right? You want to make sure you've got your core functionality down first. So if you want to build a project, if you want to build some sort of, anything essentially, don't hit it with the full prompt of everything you want to do. Think about what are the core functionalities of this product. Think about what are the things which need to work at the base level, because you're going to get errors. The LLM can fix those errors for you, but it's going to be a lot quicker if you essentially do this chaining process. And the process which I use is I create a script, I run the prompt.py file, I copy the prompt.txt into ChatGPT, I ask it for the next feature, I add the feature, and then I run prompt.py again, right? So realistically, you could probably automate this process and get it self-updating. And we've done this. This is what people call agents. So autonomous agents are unsupervised AI developers, and this is the future of what software engineering will be. They rely on what we call sort of chain of thought prompting and loops of different LLM calls. So you can think of a basic kind of auto GPT might have 3 things involved. There might be a planner, there might be an executor, and there might be sort of like a summarizer module. And what they do is they talk to one another. So you'll ask for a project, and the first one will set up its plan, right? And then the next one will then decide, okay, of these steps, what's the right order to be doing them on? And they do another pass to an LLM call, which then generates some code, right? And then there might be another module, which is the code fixer or whatever. The idea is that very easy to construct new types and architectures by just chaining LLMs together. You can arbitrarily chain together using frameworks such as Haystack and LangChain and others. Lots of different language models, not just the same call to the same language model, but different language models. And you can build these autonomous agents which are able to complete tasks in a way that we just can't. So the problem with them now is that they're limited by memory constraints. So if you do lots of these calls, right, you're going to have a summarizer module in there at some point to go, okay, well, here's the full history of what's already happened. We're going to now need to summarize that and reduce the number of tokens we're already using in the prompts. But this is an arbitrary problem, in my opinion. We're going to solve the token problem. We're going to solve the hallucination problem. And you can really envision, I hope with the demo, which it is going to work, of what I'm going to show you now, what the future of software engineering will truly be. So this is a fun one. I need a natural suggestion here of anything, not just an AI thing, of a game or a project or something. Anyone? Pun? Tetris. Really testing me here, aren't I? I did say you've got to be patient, and they are toddlers, you know. But okay, we'll try Tetris. Yeah, sure. Let's go for make Tetris. So that's all we need to do. Is type in make Tetris, and then we'll close that. Well, save it and close it. And then I'll run this. And what GPT Engineer is, I haven't built this, by the way. This is an external repo you can already clone. And it is a system which produces an entire repository for you out of a single prompt. And the first step in this execution chain is to ask areas that need clarification. Okay, so what platform? So what we're going to do is we'll say we want this to be on Pygame / Python, because we don't want it to start generating an iOS app. Remaining unclear areas. Okay, so it's going to start producing questions. So let's just get through this pretty quickly so we can start seeing the code come out. Let's just say simple for every single one. See, they don't need a lot of prompting, these things. What is the time frame now? Nothing more to clarify. Okay, and then now what this is doing is it's going to start planning, right? So this is now a planning step that's being executed, and it's planning out all the different code it needs first. So this it hasn't generated any code yet. It's first of all taking the planning step, and then it's going to pass this plan, once the plan is complete, to something that will then start generating all the code. And then there we go. It's now going to start writing the code for each file, and I don't know how long this one will take. It's quite a lot of, 13 classes. But maybe we can let it run in the background and see if we can play it at the end. But what this is going to do is it's going to produce the full repo for us, every single script separated, and then at the end it will ask us if we want to run it, which never works because it's not finished yet. You know, it's GPT. It's not perfect. Neither are you. So, so yeah, I think that's pretty much where I'm gonna finish off at, and we'll come back and look at that in a second. And yeah, just the last part there. There's a lot of low-hanging fruit here. If you want to go make your millions, come up with some random architecture of auto GPTs. It might be the one that solves it all. But yeah, so the future. Where are we going? Where is software engineering going? Coming from someone who's not traditionally a software engineer. I see it as natural language as an interface. I think we're going to have a lot more sort of malleable systems, a lot more malleable code, in that if I can just type in a basic script right now, and I can just say make Tetris, and from that it's able to build Tetris from scratch, even albeit with a little issues and it's not the most efficient version. I think we're really going to see in the next few years, you will be able to just ask for anything, and the software will be created on the fly immediately without problems. And a bunch of stuff will go on in the back end that you don't need to know about. And I guess that remains the question, people might have grown up being told, become a software engineer because that job's going to be safe forever. And the question is, well, what job is safe forever? And I think what I see building things with LLMs right now as they are is that human plus AI is always better than AI, and it's always better than human as well. So if you can be the person that is using these tools now, is trying to be AI first in what you're doing, then at the very least you're not going to be left behind, because it's very easy to be left behind right now when there's a new development every single day, every single hour even. There is stuff out there. If you're on Twitter, you know what I'm talking about. So it's very, very easy to fall behind and not really know where the future of software engineering may go. But yeah, we're going to have this software that can adapt on the fly. We're going to have as well, when we fix the memory problem, these lifelong learning systems as well, where they will always be taking in context. They will always be taking in memory. And if you have an operating system on a phone, for example, that is just built from an AI, it's just an AI, nothing else. And then that is able to, on the fly, create apps for you, execute programs in any way you want, then software engineering becomes a very different playing field, and I think it becomes a lot more about understanding the systems that can create the software than creating the software yourself. And yeah, we've always got existential risk to worry about. So I'll leave it there. That is the end. We can see if it's worked. Oh, do you want to execute your code? If yes, press enter. Should we see? It's going to break, isn't it? Did the generated code run at all? No, because I didn't install Pygame. And that is the end of the talk. Thank you very much. I've been Sam. You can find things I do there. I have an AI newsletter that was weekly and now it's sporadic. And there's a new article I've just put out on weights and biases, and then you can find repos and things I play around with on GitHub there. Question? Yes. Yeah.
Hey. So kind of two parts of the same question, but do you think that you can get an AI to write software that you couldn't code yourself? Because obviously you just demonstrated you can go in and fix it, and it's quicker than writing it yourself. And then by extension, can you get it to logically divide up code so that you can raise pull requests for someone else to review, for example, and start working with it as part of your engineering team?
Yeah, so first question, can it write code, like can I use it to write code that I can't write myself? So I'm not a software developer, right? Like my background is in physics. I didn't really start doing any developing until my final year of university. And even now, I'm doing things every single day where I have no idea. I've never seen this code before. I've never seen the packages. It's a brand new region of stuff. But because the AI is able to give me that grounding straight from the outset, and also the other thing that this does, which Stack Overflow doesn't do, is produces comments, right? It can explain it. It can provide unit tests. It can, all you have to do. Another example, actually, which you can throw in here at the same time, is instead we could just say, and who hates documentation here? Anyone? Hands up. Who hates documentation? Sure. So you've just created a new repo, and you can type in the full repo, and then just say, write README. And there you go. Out it comes. No problems. So yeah, I think this can be used for stuff you have no grounding on and have never used. In terms of like opening pull requests and like being kind of more an autonomous developer. So I built something like this, which I tried for my company a while ago, which we didn't put in production, but was just sort of a more fun test, which was like an AI-powered efficiency analyst. And what it would do is it would read through every single SQL query we had in our database, and it would run it would pass the SQL query through OpenAI. It would ask for a more efficient version, and then it would run the return version against the original version and check the data lake logs for the cost and the runtime, right? And if the runtime and the costs were, a significant fraction below, it could automatically create a pull request with that change, right? And then the only thing a human would need to do is be in the loop to once a month go and check, these 50 files that have been changed by the AI. So I think 100%, software developers are going to become much more a role of maintainers until we trust the AI to maintain it as well.
Thank you. Yeah, that was a really good presentation. I was actually quite interested in the prompt.py file and kind of creating that concatenated string, converting an entire repo into a single line. Obviously now with GPT-4, if you guys have used it, there's now the code interpreter, which you can just zip your entire repo. I did it today of 500 megabytes of size and just kind of put it in there and started asking it questions, and it did fairly decently. My question perhaps is a more technical one, but I'm not really sure how the code interpreter works. Is it along the lines of creating that single line file for that? And if it is, how much more efficient is that compared to normally pasting your code in with formatting and indent, if you have like a percentage, a number of how many tokens you might be saving?
Yeah, so code interpreter, as far as I've read and I'm aware, is there essentially hosting like a Python environment within the website itself. So it's not, you can't do, for example, get it to run the stuff that I was just showing, because that all requires an API connection, and you can't set up an API to OpenAI within OpenAI. Like it can't talk anything, it can't talk outside of the space. It has no internet ability. It can't do any lookups. You can't do any API calls. So in terms of what it's actually doing in the back end, we have no idea. Like they haven't released any understanding as to how it's really like embedding your code. I think it's probably similar to what the prompt file does. I mean, the prompt script, like just for the Python inclined of you, it's essentially just looping through the full code base. Like you have to add prompt.py to the ignore list, because otherwise it adds it to the prompt.txt file as well. And this is essentially because you might not want to give it every single file that you already have. And then it just loops through and it removes the lines, breaks, removes the spaces, adds the file paths, and that's it. And I've been using that pretty religiously for the past few months as like a method with the whole, if you understand generate yes thing. Saw that on some guy's Twitter somewhere at some point. And I've just been using that ever since, and it's super, super quick way, especially if you're a person who likes hackathons, things like that. Like, you can just churn out lines of code, and yeah, they might make a mistake, and if it makes a mistake, you give it back. Code interpreter is good. It's cool. I don't know how gimmicky it is until we've got context length. Like, I'm feeling that the more I use this, the more I use all these tools, the number one restriction is not how smart they are anymore, it's just the context length. Like, I think if you could retain the logical ability that these things have with a small context for a context 100 times the size, like, we're golden for a long time. You can really do a lot with what we've already got. Anyone else? Sure.
Thanks for your presentation. I think I have two questions. The first one is from the GPT engineer, when it asks for the time frame, you mentioned now, so I was curious, what happens if you put in 2 years? Is it going to generate code for 2 years? Then the second question is, how do you prevent these systems from being like an echo chamber? So for example, you told it to generate yes if it understands the code. Has it ever told you no before? Have you used it to like challenge your ideas previously? Because on ChatGPT, for example, it could tell me the right thing and I could tell it, no, you're wrong, and it says, I'm sorry. It generates something else, and even if it's wrong, like I tell it it's wrong and it apologizes and says something else. While bad, on the other hand, is assertive and wrong, so it could be like, just take it or leave it, and it just goes on its way. So
yeah, sure. So I think the whole kind of the hallucination problem is a really funny one, because it's really just to do with the architecture, right? Like, if all it's doing is predicting the next token without any kind of introspection as to what it's actually predicting and why that's useful for the user, then hallucination isn't really going to go away. So like the example there where it said, like the time frame for this, I think that's a funny one, because that could probably be solved by going into the raw code of this, going into the system prompt and typing in, the person is making the project now. Like, that's how simple it is to use LLMs. Like, by just adding that simple phrase to whatever the system prompt is in the back end of this, we would then restrict it from ever doing that again, right? And I found examples where, yeah, it does. So the one where it says yes, it pretty much always says yes. But like GPT 3.5 doesn't. GPT 3.5 doesn't pay attention enough to the request of the user, right? Because it's still just a word, token generating tool at the end of the day. Have patience. We're almost there. A couple more years, and then your AGI will be here. All done? One more.
Hello, everyone. Thank you for the presentation. It was great. I have one specific question, may not be in this particular field. I have background in education, and I'm turning back to the university again. So I'm going to be here a bit selfish, but it can help to many students. So where do you see LMS in education? What is the future? How the professor assistants can use that in education to help students, but also to kind of have a better education system in place?
Yeah, so GPT-3 came out while I was writing my dissertation. And I'm anyone from the university department here? Yeah, it was like it's difficult not to Is it? I don't really think it's cheating. I don't think it is cheating, because I wouldn't say there were any instances where I just went, yep, that's perfect. I love those words. I'm going to copy it in. Whether it's for like planning is another one, like generating plans, generating ideas, that's useful. In terms of use in education, like I think there's a big problem in that AI, and I've spoken to, so I do like maths and physics tutoring as well, and I think one thing that really resonates with me is I remember I turned up to do some 11 plus tutoring, and the kid was 9, and I get there and he pulls out his laptop and he goes, hey, look at this. I built a game like in Python. And I'm like, well, how did you do that? And he goes, the robot did it for me. And he opens up ChatGPT and he's like, yeah, I use it for my English essays all the time, right? And this kid is 9. And I remember being at school when, you know, computers were taking off, I guess. And everyone was like sharing websites, like sharing cool things. And I'm convinced of it, you know, like ChatGPT is the secret that goes around schools, which isn't really a secret. And all these kids are using these things. And the big problem is that we can, and I know this is slightly different, like you're talking about university and I'll get there, but like we can deal with the hallucination problem because we've already been educated, right? Like we are already able to tell when it's saying, at least if you're talking about something that's, you know, within your subject, you can already tell if it's saying complete gibberish. But you know, a kid cannot. They cannot do that themselves. And to them, you know, they've now got this magic, you know, robot god on the internet that can tell them anything. Like it's a dream, right? You know, we would have loved this when we were kids. And I think the other problem is that parents, you know, see it as a buzzword. Like people aren't really fully educated on it. The teachers don't know how to teach in the age of AI. The students don't know how to learn in the age of AI. And you know, if the governments haven't solved TikTok, then, you know, are they going to solve this? And I think there's definitely a need for like investment and growth in kind of a private sector to like to going into schools and working on this stuff. And then more on the university side, like a lot of professors embrace it, and I think that that's the most important thing. Like I see, I follow a fair few like Twitter professors. Professors on Twitter, and yeah, like a lot of them say, like, you know, what we use LLMs all the time. Like I let my students do things with LLMs. Like they just have to make sure that all the stuff is referenced. And you know, other examples like creative writing professors, for example, they did one where like an assignment where you had to creatively analyze the outputs of ChatGPT and, you know, compare it to your own or enhance the work. And I think that that's the thing. People need to be less afraid of these things in that they're gonna make everything worse. They are just tools. We need to learn how to use them a lot better. We need to educate teachers and kids and everything on how to use them, and how we do that, yeah, it beats me, but someone out there knows how. So yeah, I hope they work it out.
I'm just going to step through because for everyone here with us, we actually have this venue for another hour, so please do continue asking questions, chat, but we do have to go over to the breakout rooms for everyone who's joined us on Zoom. So what we'll do now is we'll probably stop sharing screens and we can all just mingle here in person, and I will quickly run to the back to a phone booth to join some breakout rooms. To Julian, I think we can start that now, and please do continue.